welcome to another session of Elimu Glass. This is our second last lecture on the series on triangle laws, and this is going to be a discussion of the cosine rule, right? I want to thank everyone who's been watching and giving encouraging comments and suggestions. Thank you very much. Keep watching and spread. These lessons are free, so please help those who may not be able to see them. Share them widely so that they are able to take a look, and probably, hopefully, we are able to help somebody who might need to understand some of these concepts, okay? Under the cosine rule, we will go back to the triangle that we were using, triangle ABC, all right? The lowercase a, b, and c will represent the opposite of the angles of capital A, B, and C, just like before. This time, again, we draw a perpendicular from B to join AC at point D, okay? We will name side that perpendicular height BD, we will call it H, but this time we want to refer to the length AD as X, all right? And since the whole length AC is B, and this bit is X, then DC has to be B minus X. So I can remove the B there and then put B minus X as the length of DC, okay? Now, if we use Pythagoras' theorem, we know that C squared is H squared plus X squared, right? So for triangle ABD, C squared is X squared plus H squared, but I'm interested in making H the subject of the formula, so I can say instead that H squared has to be C squared minus X squared, all right? Similarly, on triangle BCD, H squared is A squared minus into bracket B minus X, this one here squared, all right? Like that. Okay, now H is referring to this same height. That means that equation 1 and equation 2 are exactly the same thing. So we can equate them, and so we get rid of the H there. So if we equate them, we get that, all right? Well, I haven't shown how I've opened that bracket. We can show, let me just go back briefly so that we can show this expansion here. I could say, I can write here that C squared, so from equation 1, C squared minus X squared must be equal to A squared minus into bracket B minus X, everything squared. If we open this bracket, this is A squared minus, open that bracket, we will leave that negative out there and we open this bracket, and this gives me B squared minus twice BX plus X squared. Hopefully you can now open the bracket quickly. And now if we remove the bracket, we have A squared minus B squared plus 2 BX minus X squared. All right, so now we have C squared on the left-hand side minus X squared is this. All right, and that's the expression that I wrote. So I skipped a bit of steps so that we would move faster. Hopefully you get this. Yes, okay. And therefore we equated them and got that on both sides. Now you notice that there is a minus X squared on the left-hand side and a minus X squared on the right-hand side. We can cancel those. So becomes C squared becomes A squared minus B squared plus 2BX. The other thing I want you to note is that using the basic trigonometric ratios, we can see that cosine, we can write here, that looking at triangle ABD, using very, very simple basic trigonometric ratios, we know that cosine of the side A is the adjacent over hypotenuse, so it must be X divided by C, and that means that X can be expressed as C cosine of capital A, which means where there is X, this one here, this X here, I'm going to remove that and replace it with C cosine of A. All right, so replacing that, think I will just open. Okay, so x is c cosine of a. I'll clear this and start again. So c squared is this. And we've also determined that x can be replaced by c cosine of a. So if we put that there, we end up with this. All right, this is essentially the cosine rule. But now let's place it in the form that you will find it in the formula booklet. All right, so we will make a the subject of the formula in one case when we want to find the length of an unknown side. If we want to find an angle, an unknown angle, then we make cosine of a the subject of the formula. So if we do that, making a squared subject of the formula, we end up with this. And this is the cosine rule. All right. Alternatively, we make cosine a the subject of the formula, and we end up with that. This is effectively what the cosine rule is. It's just how to make use of it. So let's look at an example of how we use the cosine rule. First of all, when do we use the cosine rule? Okay. The cosine rule becomes useful when you are given two sides. So S and S there means two sides, and the angle that they form was what we refer to as the included angle. So that's one instance. Here is the diagram. We are given an angle, an included angle of 5 and 8. So when we are given this, we can use the cosine rule to find the unknown length there. And if we have that, we are now able to find the other angles accordingly. All right? Alternatively, we can also use the cosine rule when we are given the length of the three sides, S for side. Okay? So if we know that, we know this, and we know that, and we didn't know any angle, then we can use the second form of cosine rule to determine the unknown angles. Here is what we are talking about. So we have the three sides there, 7, 10, and 12. We are looking for the angles. Here again, we can use the cosine rule. Okay, the question is, why can't we use the sine rule? Why can't the sine rule work? Now, if you go back to the earlier videos, the video on sine rule, which was the second video really, we say that we use the sine rule when we are given two sides and the non-included angle. So here we have an included angle. So we have 8 and we have 5 and the angle that is included, the angle that they form. All right? For us to use the sine rule, we need those two sides and a non-included angle. So the angle opposite the 8 or the angle opposite the 5 would be a non-included angle. And remember, if we are given the angle opposite, if we are given the angle opposite the 5, the smaller of the two lengths, then we end up with what we call the ambiguous case of the sine rule. Okay? So therefore, we cannot use the sine rule there. Similarly, in this one, the alternative is that we are given two angles and one side. And you can see in this case, we are not given the angles. We have three sides, but there is no angle that is given to us. So once again, we cannot use the sine rule to determine any of the unknowns. Okay? All right. Next is, can we find the area? What about the, remember the triangle, area of triangle rule? Can we find the area of the triangle? Well, in this case, yes, we can find the area of the triangle because we have been given the two sides and the included angle. And when we are given that, then the area is simply a half times the product of the two sides times the sine of the angle between them. So yes, we can find the area of this one. What about this one? Can we use the area of triangle rule to find the area of this one? The answer is no. And this is because we need an angle, just like we have an angle there. We need to know one of the angles in order to be able to find the area of the triangle using the area of triangle rule. Still, though, we can find the area of this triangle. Okay, so although we do not discuss this in the diploma program, when I teach these concepts, I always try to go wide for the sake of someone who might want to do this for their IA, all right, the internal assessment. If your IA is based on triangles and so on, you may choose to go as deep as looking at other ways of finding the area of a triangle. And in this case, we use something called Heron's formula. Heron's formula there, as this guy is saying. And the Heron's formula says that for a triangle with sides A, B, C, so let's say this is the side of length A, this is A there, let this one be B, and let this one here be C. So given that, the area of the triangle is found by the representation. Formula A is the square root of S into S minus A into S minus B into S minus C, where S is referred to as the semi-perimeter, okay, or semi, as Americans like to say, semi-perimeter, which is just A plus B plus C, which would be the perimeter of this, but semi means half of it, so divide by 2. In our case, this would be 12 plus 10, 22 plus 7 is 29, so 29 over 2, which is 14.5. So our value of S is 14.5. The values of A, B, and C are basically just the sides of the triangle, and therefore our area here would be, the area is going to be S, the square root of 14.5 into 14.5 minus, say, 7 is 7.5, all right? 14.5 minus 12 is 2.5, right? And 14.5 minus 10 is 4.5, like that. And this becomes the area of our triangle. If I use my calculator, I'm using a TI Nspire. If I use my calculator, I think I already did this, I get 34.97, so approximately 35. The area is approximately 35 square units, whatever the units were. If this were in meters, then this would be meters squared. If this were in centimeters, this is centimeters squared. So that's how you would find the area using Heron's formula. Remember, S is called the semi-perimeter, and then you use this formula up here. That is the area of this triangle. We cannot use the area of triangle rule that involves an angle in this case, right? I hope that was useful. Now let's go ahead and try and find, say, the unknown side here and the unknown angles here using the cosine rule, right? Let's just try and find these things out now. As an example, find the unknown side length of this triangle. So let's let that side that is unknown, this one here, let it be x. If we let that be x, then we can make use of the cosine rule. Since we are looking for x, we use the first form of cosine rule, a squared. So this would be our a, because that's the angle we're looking for. So a squared becomes b squared plus c squared minus twice bc, right? So this is b and that is c. So b squared plus c squared minus twice bc, the size that we know, cosine of 60 degrees. So if we do that, we get x squared is that, simplify that on your calculator, all right, that is 49, and x, in fact, we don't need a calculator there, it's easy. X there is 7 units, whatever the measurements are in, okay? Hopefully that's not difficult. Let's look at the next. Now we want to find the unknown angles alpha and beta. This should be more interesting. Because we know the known side, we are looking for an angle, we use the cosine rule in the second form. It's not a must really, you could still just use the method of the first formula, but if we make cosine of alpha subject of the formula, it makes life just a little easier. All right, so to find angle alpha, we need the forming sides of 7 and 10. To find angle beta, we need the forming sides 7 and 14, like that. And so using the cosine rule in the second form, we can say cosine of alpha. In our case, it's going to be cosine of alpha. All right, so cosine of alpha is 7 squared plus 10 squared minus twice, minus, first of all, 12 squared, and then divide by twice 7 times 10, like that. And if we use your calculator, right, to find the cos inverse of 1 over 28, we end up with 88 degrees. So that means angle alpha there is 88 degrees. Similarly, we can find angle beta. This time the forming sides are 7 and 12. So 7 squared plus 12 squared minus 10 squared, everything divided by 2 times 7 times 12. And if we feed that in the calculator, we should end up with 56.4. Please do this and confirm that these are the answers. 56.4 degrees for angle beta. Really straightforward. Let me know if you're facing challenges with these questions. Hopefully it is not that bad. Okay, here are some examples that I want you to try out. All right, pause the video and take a look at this. At the end of, after about 3 days, I'm going to put the solutions to the question in the discussion below. So take a look and let me know what you think. Here's a problem 2, same thing. This just requires you to make Q the subject of the formula. Express Q as a function of P, okay? Here is another one. Problem number 3 is an exam style question. Again, not very difficult. Please remember that angle M there is not 90 degrees. Angle M, LMO, which basically is angle M there, it is not 90 degrees, so do not assume that it is 90. Okay, answer those questions. All right, and here is another one. I've said here HL, but when you actually look through it, it is not really an HL question. This could be done by any student really who studied triangle rules. All right, try it out and let's see what you get. Okay, and that brings us to the end of this discussion on cosine rule. I hope that you were able to follow. Let me know what you think in general. And if you're not already subscribed, please do subscribe to the channel. Like the video so that you will be notified whenever any subsequent lesson is posted. Thank you very much.